very much for the wonderful introduction, and thank you all for coming, for joining me today. It's an honor being here in front of you. This is my first time at Codebeam America, right? So, Against the Grain is the title of this talk, and I'm trying here to capture the main message which I want to drive, and this is the idea that sometimes we have to do things a little bit differently. Sometimes the approaches, the techniques, like the patterns, which are considered to be like mainstream or idiomatic, do not necessarily work for us. When it's up to us, to figure that out, to see that we have like a special situation and make some different kind of choices. Now, I'm not advocating being different for the sake of being different. I think that this is like very counterproductive, probably equally counterproductive as mindless cargo culting. So what I am advising is be a little bit critical about everything you apply, right? So of course that when you have a problem, you're gonna reach for a widely recommended or popular solution, and usually it's gonna work fine for you. Presumably this is the reason why it's popular, but do spend a little bit of time thinking about does this actually make sense in my situation, and then you'll be able to easily identify your special cases and make some different choices early on, and then save you some time and a lot of nerves, I would say, right? So that's like the main message that I want to drive. But this is going to be a very technical talk. I'm going to do a case study on a thing that I did for one of my clients about a year and a half ago, and this was the challenge, right? So communicating with Apache Kafka from Elixir. And so just to make sure we're all on the same page here, you don't have to know a lot about Kafka. For what it's worth, I knew nothing about Kafka when I was doing this, and I still consider myself to be a noob about the topic, and so you don't have to know a lot. So just in one slide, what is Kafka? It is a program, written by other people. This is always a good thing. We don't have to maintain it. We take it off the shelf, install it someplace, and it runs, and we use it, right? So we interact with it. And so we have our own programs interacting with Kafka, and some of them are called producers, and they are producing events, which are also known as messages and records, right? And so I'm going to use these terms interchangeably. And so basically, event is arbitrary piece of data, whatever makes sense in your particular system, and they are categorized across these topics, right? And so topics are kind of like folders or database tables. These are the things you create on your own when you're administering Kafka. And so in the producer, you're going to just communicate to Kafka, here are some bytes and put them on topic foo, and this is producing one event, and then here are some more bytes for topic bar, and so on and so forth. Now, on the other side, you're going to have your programs which are consumers, and they are going to connect to Kafka, and they are going to subscribe to the desired topics. And then they are going to be receiving the events as they are produced, in the order and with little latency, so it's near real time. Right, so this is the general idea. You're going to get some nice goodies from Kafka. You're going to get some durability, so your messages are not lost. You're going to get some tools and means to get to the desired processing guarantees, at most once, at least once, exactly once, whatever you need in particular case. And then most interestingly, there is this thing which is known as group consuming, which I like to think of as basically as distributed consuming, where you start multiple consumers that handle the same topic, and they somehow spread the work between themselves. So one message goes to consumer A, another to consumer B, and so on and so forth. And this group is dynamic, so they join and leave, and this basically gives you means to reach horizontal scalability, right? To scale per load, and also to get better fault tolerance, right? So this is Kafka in a nutshell. We could probably spend the entire talk, discussing it, but I think this is going to be mostly enough. I'm going to drop a few other bits of pieces down the line in this talk. So, okay, you need to talk to Kafka from Elixir, So how hard can it be? What are you going to do? You're going to go to HexPM, and then you're going to type Kafka, and you're going to get some search results, and the three here are, there are going to be more results, but these will be the foundational one, the founders of the houses, if you will. So you have, all the others are basically wrapping some of these, right, or one of these. And so you have the first two, Broad Kafka EX, they are native ones, so implemented in Erlang and Elixir, respectively. And then EarlCaf takes a somewhat different approach. It wraps a popular C library, which is called Liberty Kafka. And so basically, EarlCaf just provides a wrapper to the Erlang and Elixir world, so it's like a NIF-based thing. And so a lot of heavy lifting then is done in that C wrapper, which is again maintained by someone else, So that's by a wider community, so that's a good thing. So if your needs are like reasonable, you're not like super demanding in terms of specifically in terms of features, then either of these is going to work fine. And as far as I have seen, people and teams are using those libraries. But if you're more demanding, like my clients are, then you might end up into some trouble, right? So my clients, they basically have like they're heavily microservice, right? So they have something like 200 plus Elixir-based microservices, and it's constantly growing. And they use a lot of Kafka to communicate between those services, right? So they, produce a lot, consume a lot. They need to do a lot of different modes of operations with Kafka, and they kind of find the experience of a mixed bag, right? So they used EarlCaf primarily. So 6 years ago, their assessment was that this is the client that gives them the most of their needs, but not all of them. So they actually use the other two as well. I think they have like one service or project where they use all three together, and still they didn't get everything that they wanted. Then there were, like, of course, some problems, like some things missing and some, things being buggy. So they were, trying to fork and fix the EarlCaf, but, being an if-based thing, then, they find it difficult to wield because, you need some C experience, and not many people were willing to do this. And so, ultimately it fell on just a single person, to maintain this thing. And then, that person was not a happy person. So I can tell, like, from what I heard from first-hand experience. And so that was the problem, like specifically with EarlCaf. The other two, so Broad and Kafka X, of course, being written in Erlang and Elixir should be easier to maintain, but do require more work. Because the thing about Kafka is that it offloads a lot of responsibilities to the client. So you have like a fat and smart client, and so you have to do a lot of work to, support all the features. And so I want to specifically highlight the first two features. So these are like kind of recent additions to Kafka, and by recent I mean 2019 or so, definitely pre-COVID, right? And so they're still not supported, and specifically in one of the projects, the maintainer explicitly says on the issue, we do not have plans to support this period, which is perfectly fine. So this is not a criticism of the maintainers. We can only thank them that we get this work for free. But the thing is, my impression, as I said, I'm a noob on the topic, but my impression from what I've seen is that, like, for this amount of work and smartness required in a Kafka client, this kind of pro bono open source style is not going to cut it. Like, you need a person who's actually on a payroll or a small team, on a payroll to actually, make this happen, right? And until that happens, you're not going to get first-class experience with Kafka, in the Beam world, right? And so if you want that, go with Java, right? So that's my advice. You can quote me on that. You have a famous author here, Diondias, he can help you buy his book, give him some love, right? But yeah, I'm specifically mentioning Java. Yeah, still a classic, right? No, I'm specifically mentioning Java because Java client is the official client, So it is the only client which is a part of Kafka repository. So it is developed, tested, released together with Kafka. And so you don't get to be more up-to-date than that and more mature, and feature-rich, right? So, like, that's your option. And then what you're going to do, like, if you pick Java, basically you're going to pick your language and runtime based on the quality of your Kafka client. And you're going to do way more things than just talking to Kafka, right? So this is kind of a weird choice, Like, I like to pick language and runtime because, they have some other good properties, And I like Beam, It gives me fault tolerance, right? It gives me high availability and stuff like that, right? And so that's what I want, But so if you don't want to sacrifice that, and you want to stick with Beam, then you can do what my clients did. Basically, you can suck it up. Right, so they basically learn to live with all these deficiencies and flaws, they improvise around that. So, like, these people live in the same city as myself, and I would bump into them every now and then, and that they would always rant about their Kafka experience from Beam, So they were not happy people, But those are your choices on the table, right? So, like, I would say that they're, like, not very good choices. And so, I want to have, like, be able to use Beam and all the goodies of Beam, and I want to have first-class Kafka experience without actually having to write a Kafka client and maintain it on a full-time basis, right? So can we get that, right? This is possible. And so what if, and please don't, throw, like, eggs and rotten tomatoes and stones at me, but, like, bear with me for a while. What if we could somehow combine, like, Elixir and Java in the sense that, like, I write 99.9999999% of my code in Elixir, and then I have, like, this teeny tiny layer written in Java, which, just uses the Kafka client, and then I I have, all that stuff available, right? So that sounds kind of promising. So maybe we can do that. So let's give it a try, right? How are we going to find out if this is possible? You can go to the AI, or you can ask the Boomer tool. Either way, you're going to get like the same answer. So basically, you should use a thing which is called JInterface, right? And so JInterface is a library. It's a Java library, but surprisingly enough, it's part of Erlang/OTP. So Ericsson maintains it and releases it. And this library allows your Java program to act like an Erlang node, And so you can basically connect to other Erlang nodes, and they're not going to know your Java, and so they're going to tell you everything. They're going to be willing to talk to you, And so now you can interact with Beam and non-Beam, right? So this is like super, super interesting thing. And surely this is the thing that you're going to use, right? This is widely recommended, wherever you look. And, my advice is don't do that, right? So taking a step back, so what we want to do here is I want to write a subroutine in Java. And to do that, I need to start a Java program. And basically, it's going to live as long as I live. If I'm gone, then it should be gone too. And I'm going to tell it what to do. I'm going to lead. It's going to follow. It's going to give me some results back and whatnot. And so you can shoehorn this into distributed Erlang. But I really think that you're going to end up with some problems that you shouldn't have, net splits and separate life cycles and whatnot, And yeah, I don't think it's a good fit. And from what I can tell you, these people, this team, before they approached me, they actually tried JInterface, and they kind of got lost into these details and basically gave up on what I believe was essentially a good idea, but they went down the wrong implementational path because such was the advice, in the wild. So yeah, no JInterface, that's not my advice. I prefer to use a thing which is called port, right? And port is basically, it allows you to start an external program and then communicate with it through file I/O, through pipes, right? And so this is the thing that works really well when you want to combine Beam and non-Beam. So let's take a look at briefly how does that work. So you invoke some standard library function. This one is from Elixir, and then you tell it start me this executable, and then you pass some arguments to that executable, and then you can pass some other options, which I'm not going to go through. You can redefine manual. Yeah, but so here I'm starting the Java executable, and then I'm giving it path to jar. This is my compiled code, and then the class name, and then it's going to start that thing. And the result of this thing is the data of a type called port, which is one of the foundational data types, and it's kind of like a PID for an external OS process. And so now you can interact with it through this variable. Now what's going to happen conceptually, you're going to have established two pipelines between Beam and your Java program, or two pipes, right? So by default, Java is going to use standard I/O. So basically, you can read from standard input, and this is where your messages from Erlang or Elixir from Beam are coming, or you can write to standard output, and that goes to the Beam side, right? So that's the general idea. You can use different set of files, so you can liberate your standard I/O, and this is what I tend to do. But the caveat here is that then that's not going to work on Windows, right? So if that's important to you, then don't do that. Otherwise, I like to do that because then I can do debugging and logging on the standard output specifically. So anyway, once we open the port, then this is how you can send some message to the port, right? To the external program, to Java in this case. So message is just a bunch of bytes. So you have some data you want to send, you're going to encode it. You can use JSON, or you can use protobuf, or if you only live once, you can use YAML. We are using a thing which is called Erlang term format, or external term format. So this is the stuff you get when you do Erlang term to binary. So you have an arbitrary term, it can be a tuple, or it can be a map, or whatever. You invoke this function, you get some bytes. And then there is an inverse function which just gives you back the same term, no impedance mismatch. So it's very convenient thing, and that's what we've decided to use. So anyway, you're going to send some bytes. Oh, and I just want to say, so this format is documented in the Erlang documentation. So you can write encoders and decoders in other languages. Typically, they are available already. So in Java, there is a library which does that for you for free. And that library is called JInterface. And so, contrary to what I have said, we are using JInterface, but not for the distribution, for the communication, just for, this coding and decoding, right? So again, you have to go against the grain, right? What can you do? But yeah, anyway, so here I'm sending some bytes to the other side, right? And so on the Java, oh, and physically what's going to happen, these are the bytes, the raw bytes. So you're going to have like 4 bytes representing the size of the payload and then the payload itself, right? And so this goes to Java. And so then on Java, you read like 4 bytes, you read n bytes, and then you have your message, you decode it, and then you do whatever you want with it. The opposite direction, write 4 bytes to the standard output, write n bytes, write your payload, right, and then you're good to go. This goes to Elixir, and then you're going to get this kind of message, and you do with this message, you do like Erlang binary to term to get your term again, and then you can do whatever you want. So that's the general idea. That's basically message passing mechanism between Elixir and Java. And so now that we have this established, then the sketch of the Java program would look something like this. So I'm going to loop until I get end of file. I'm going to get end of file on the input when the owner process, typically the process that started this Java program, or the entire beam stops. Normally, abnormally, it doesn't matter. That's when I'm going to get the end of file, and that's when I should stop myself, right? And otherwise, I'm looping. I wait for the message. I process the message, optionally send the response back. And so if this sounds familiar to you, it's because it is, right? Does anyone recognize this, maybe? What is this? No? It's a gen server. With the whole shebang, right? So, like, it has, nothing shared concurrency. It has separate memory spaces, fault tolerance. It has separate scheduling and whatnot. And this is what I like about this this approach, right? So it's very Erlang-y. It's very OTP. It fits right there into my mental model of how I like to do concurrency. What I'm doing with the rest of the code, right? And so this is what I like about ports. They fit very, very nicely into the whole story, right? So I'm not going to say that they are always good, but they're going to be the first thing I'm going to consider when I want to interact with something outside of Beam. Yeah, that's basically like the general story. And so let's take a look at how wrapping one API would look like. I'm not going to go through the implementation. We're just going to take a look at this usage, right? So this is some code. This is Java code, by the way. So like if you see some semicolons, that's Java, right? Or you can ask Bruce if you're not sure. He's going to tell you. So here I'm using an admin API, right? So like Kafka has 3 different APIs: producer, consumer, admin. I believe the names are pretty self-descriptive. And so here I'm using admin API, which means I have to instantiate an object, and typically you're going to hold on to this object for a long amount of time because of some caching and established connection and whatnot, and then you're going to interact with this object to do this and do that, right? And so here I'm trying to describe some topics, like I give him a list of strings, like these are the topics, and it gives me some properties back, So that's the Java, right? And our Elixir version looks like this, so it's very, very similar. So I'm just going to explain it, roughly what goes on. So like I start link some process, and this is going to be a gen server. That gen server, in its init, is going to start the port, and port is going to create the object, and it's going to keep the object alive, right? And so that's the first step. And then when I do describe topics, this is going to be a gen server call. I send this stuff to the gen server. It packs them, sends them to Java. Java decodes them, does the job, sends me back the response to the gen server, back to me, right? So that's the general idea. I think it's pretty straightforward. So the downsides are, like, there are 2 extra hops, and there's some extra encoding, decoding. That may or may not be a problem. You have to think about your own particular case. I would say typically, in my experience, stuff is gonna, the stuff that's gonna dominate is gonna be the processing of the event itself. So this is usually not gonna matter, but it may matter. So, think about that thing. That's the price you pay. You always have to pay the piper, right? So that's one thing. And of course, behind the scene code is, gonna have some like extra ceremony or bureaucracy, boilerplate. You can expect something like few dozen lines of code, like 2,000 to 3,000 lines of code per like this single invocation. So that's quite a lot, but it's stupid code, mostly just describing how we encode and decode stuff. Not very smart code, right? So you're going to write it once, dial it in, and typically you're not going to have to revisit it often. And so this is one big point. My advice would be, as much as you can, this is how you want to do. You want to wrap API one-to-one to what's the original API. That means that like you're going to reduce the amount of smartness in your external program, like in Java. And that's what you want because people on your team are primarily experienced with Elixir, right? And so you don't want them to be also Java experts. They need to know a little bit of Java, right? But presumably, the less the better, simply because, it adds a lot of extra overhead, right? And so that's the general idea. But sometimes, you're going to have to go against the grain, right? Sometimes, you're going to have to make some different choices. And so let's see one such example. So this is an example of how we're using in Java, the consumer API. So I create the consumer, I tell it to subscribe to some topics, and then I'm looping, and basically I'm polling. So polling is a blocking operation. It waits for some time, gives you some records, right? So like events, the messages, 0 or more. And then you do for each, and then you do something with those records, and rinse and repeat. Now, the key thing here to understand is that you have to do these polls regularly. So like if too much time passes, this is configurable, but ultimately there is like some time limit. If too much time passes between 2 consecutive polls, then you're going to be presumed as inactive and you're going to be kicked out. Right? And this is like you can recover from this event, but you want to minimize the amount of such events because they're going to be disruptive to the way you're consuming. Right? And so you want to try to pay attention that this doesn't really happen often. Right? And so my initial idea when I was implementing this it was to do this in Elixir, right? So wrap the API one-to-one, drive this loop from Elixir. And the problem there is that then I have to wait for the poll feedback to come all the way to Elixir. And this means I'm going to have to wait for records to come to Elixir. Typically, this is fine, but you may encounter like it basically takes just one record, which is like super large, like think in terms of 100 megabytes or something like that, which is an anti-pattern, but still can happen. And then you have to wait for that record to be encoded, sent back to Erlang, and then decoded, and only then can you actually start polling again. And so that's kind of risky. And so for that reason, I decided to keep the loop in the Java, because it improves my chances of ticking regularly. So what we're doing is basically something like this. So we have Java divided in 3 threads, and they communicate in a message passing style, right? Which was actually surprisingly elegant to be implemented in Java. And so I had like this input thread, which reads from the standard input, and then the centerpiece is the polling thread, which runs that loop just as I have shown you. And what it does is when it gets some events, it immediately sends them to the outside, to the output queue. And then resumes polling. And this is like super fast operation. You have to grab some lock, you have to put some reference someplace else, and then you release the lock. And so that's like blazing fast. And essentially, I think that, and so then the output thread is separately going to encode this stuff and send it to Elixir. And as a result, I think that like our chances of missing the beat are vastly, reduced, virtually 0, I would say. So like I can only see this happening if the whole system is like super overloaded, And so this is a good thing. And so with that, our porcelain API would look something like this. So you start link a gen server, you give it a list of like Kafka servers or brokers, you give it a group ID. That's irrelevant for this talk, but the important thing is, I'm going to give some topics to subscribe to, and then this handler thing. So handler is a function, which is going to be invoked for every event, or rather for every batch of events. We do some batching, that's kind of an aside for this talk, but this is where you're running your code. This is where you're going to do your own custom handling. And this handler is going to be invoked in separate processes. So this is a simplified version of our process structure. And so here I'm going to expand something about Kafka. So there's like this concept called partition. This is effectively sharding for topics. So topic is subdivided into partitions, and that allows you to have different consumers consuming from the same topic. Because multiple partitions or different partitions can be consumed separately. A single partition should be consumed serially, and yeah, so you have like each consumer has some partitions assigned to it, and this is a dynamic assignment. So like this stuff comes and goes, Like now I have partitions 3, 1, and 4. Maybe like in 5 minutes I'm going to have some completely different set of partitions, So this is kind of dynamic. This happens as a part of coordination with other peer consumers. And so this is our process structure. So like whenever you get an event, it's going to be forwarded to the partition process, and this is where we're going to invoke your handler function. So like we can do this concurrency per partition. This is what we have in that library. All the other 3 libraries also do the same thing, and it's very intuitive. Once you understand the Kafka rules, then it's very intuitive that you're going to use this thing. It's nothing fancy. It's like plain regular Erlang style concurrency, just regular day at the office, right? So that's what we do. Java people, my impression is like reading the docs, using the Google. So back then we didn't have AI, but I actually tried also asking AI. You are wildly pushed into single-threaded model of consuming. Like you poll, then they tell you like do this as fast as possible, consume, poll again. Everyone goes there. Like don't do concurrency if you don't really need to. Don't go there, right? And I understand that. I came from .NET background. I used to do a lot of .NET and C++ before that, and I understand this fear of concurrency. But we don't have this in Beam, right? So like this is our normal tool that we use, extensively whenever it makes sense. And so to me, this is basically the essence of what we did here. So like we have the best of both worlds in a sense. So we get like this great Java client, first-class client with all the bells and whistles and whatnot, and we add value on top of it by, adding this Beam-style concurrency, and so we make it like very, very nice to use, right? So this is really a cool thing, at least to me. So the final thing I want to talk about is dealing with back pressure. So the essence of the challenge, like when you're ingesting something, like stuff comes in, you do some processing, stuff comes out, like you're gonna do some side effect to database or push some messages, further messages to Kafka and whatnot. And so if you're slow compared to the incoming rate of messages, then some queue is gonna grow and ultimately you're gonna blow up, right? So you have to make sure that, you react in such situations, and this is sometimes referred to as, applying back pressure, or sometimes also as managing back pressure. And so how do we do this in Elixir? Like again, you can go to hex docs or hex PM, right, and type back pressure, and what you're going to get is gen stage. So this is the library for back pressure, co-written, co-authored by Joseph Alim. So surely it has some street cred added to it. And again, this is not what we use in this situation, which does not mean that gen stage is a bad library, but I don't think it fits this scenario. So like I spend some 2-3 hours, I think, thinking about this intensively, and I figured that this is not a good fit for us. So let me try to explain this story briefly. So this is the flow of events through our system, simplified version, right? So stuff comes to Java, then it goes to some gen server, and then that gen server distributes this across these partition processes, which are dynamic, so they come and go, right? And so the problem is then, like if one partition process, like say P1 is slow, and so stuff piles in here, and these are good, so these are perfectly fine, right? The P2 and 3. And so what you want to do, and what Kafka client allows you to do, is you can pause consuming on an individual partition, right? Pausing means, you're not going to get more events until you explicitly resume, but you're not giving up the ownership of that partition. It's still yours compared to the other consumers in the group, So that's an important thing. Right, and so that's basically what we do, and the way we do it is like pretty straightforward stuff, So essentially, in Java, I keep track of all the events I have passed downstream. Like I give event to Elixir, and I'm gonna keep note of it. Like I have one event on partition 1, right, and so on and so forth. And then when I consume the event here, I'm going to send an acknowledge message back, like I have consumed this event. And so I can remove it, Java can remove it from the internal records. And as a result, at any point in time, Java program knows exactly how many events we have in flight per each partition. And so prior to each poll, it can figure out, okay, queue on P1 is too large. I'm going to pause P1. Everything else is fine. And conversely, like once the size drops, we can figure out, oh, I can resume consuming from P1, right? And that's what it's going to do. It's as straightforward as that. You could maybe, I'm not sure, I spent some time thinking about it. I think maybe this could be done with GenStage, but essentially you would have to implement your own buffer, and you would, I think, have to implement a custom dispatcher. And at this point, the question is what GenStage gives you, and I think it only gives you problems. It's because you have to put this into the vocabulary of the GenStage, right? So, like, I think that it would be interesting to turn all of this into a single stage, because then you can combine it with some other processing stages. It would be very interesting to implement a Broadway interface for this, or adapter, right? So there is this thing called Broadway, which is like an abstract ingestion thing, doesn't care about the data source, you give it an adapter. So this would be a very useful thing. We didn't do it because we didn't need it, but that would be a cool thing. But I don't see GenStage, making sense directly here for back pressure. And, we just didn't use it, and I think it's fine. So in summary, you could say that we have taken a road less traveled by, and it has made all the difference, right? So we made a couple of unusual choices, and we were able to solve the problems of my client, right? So they have their needs fulfilled, they sleep more easily, and I think a very interesting thing is that now, they are in a strategically good place because the future stuff, supposedly some other features are going to come to Kafka over time, is more easily available to them. So they have to update the library. They will have to do some coding in Elixir as well, but it seems like more easy to attain than with the existing clients. So yeah, they have been using it in production. They have been slowly but surely translating to this. For what I understand, they have some good experiences. But yeah, you can ask them directly if you want. I'm going to give you the link to the repo at the end. So yeah, of course, everything comes with a trade-off. As I mentioned, you pay the price in speed because of this extra encoding and hops. Maybe it's a problem, maybe it's not. You have to consider it for yourselves. We are only wrapping like a very small fraction of the API, basically just what they needed. I think this should suffice many cases, but for everything else, you're going to have to add some more stuff. Does require Java knowledge, but as I said, mostly not a lot. We try to keep the smartness out of Java, except in this consuming part. And then most notably, you're going to have Java runtime environment installed, and you're going to have to run that instance of it. So that's your price as well. May or may not be a problem. It depends, right? The stuff is available here on GitHub, so take a look. Don't be too judgmental about my Java. Pardon my French. It was like the first thing I ever wrote in Java, also the last. But yeah, so the stuff is there. Take a look and let us know how you like it and does it make sense. And so that was basically all I had prepared. So thank you.
Thank you, Saša. We have a few minutes if you can take a few questions on the app or in person. Bruce, do you need to say some things back to him?
Sorry about that.
Do you ever have to deal with zombie processes, and if so, what do you do?
With zombie OS processes, or which zombie processes? The key thing is writing the port in a way that you can prevent it happen, So let me just go back there, right? So if you don't do any work here other than just ingesting from standard input, then when you get the end of file, you can immediately exit, like this. And that's it. Yeah, I mean, I also wrote, I was just discussing with Frank earlier today, I wrote one wrapper, Frank wrote one wrapper around ports, and there are like two famous other wrappers around ports for this particular situation, specifically because I also wanted, to keep things simple for my clients. I didn't use any wrapper, and I think as long as you do this very simple logic here, no processing here at all, just read the input, immediately push it elsewhere, and rinse and repeat, and then you're good, because then you can immediately detect end of file, and you just terminate like now. Does that answer the question?
I'm not sure about the amount of messages you guys were processing in a time range, but for instance, if the message size is too big and you have to decode that in the Elixir app, and probably that would spike memory. I don't know if that was the use case, and if it is the use case, the solution would still be suitable for dealing with very long messages where you have to decode and might create memory spikes. Probably might create unavailabilities in the app, or you just have to pay a lot of money in order to have a lot of memory.
So this is an excellent question, right? First to answer, I did some synthetic tests. That was pretty much the initial thing I did, with very large messages, and stuff works, but it's obviously slower, simply because, you pay the price. I didn't much pay attention to memory, though, I have to say, but I didn't notice anything unusual in unexpected in growth in terms of memory size. That being said, the stuff we did is not super optimized for that, especially because we're using Erlang term format and Erlang binary to term. So you just get immediate, decoding of everything rather than maybe some streaming-based stuff which could keep the memory usage constant, which would be the solution for that scenario, So it would require some changes. It can be done, definitely can be done, to keep the memory stable with the expense of something else. Was that the question? Yeah. Was the answer okay? Yeah. Okay. I mean, do you have some, yeah, okay.
Any other questions? All right, thank you.
Thank you very
Saša.
much.